12 resistances each of 1 ohm are connected to form the sides of a cube. So this is a cube, and in each side suppose you have 1 ohm resistance. Find the effective resistance across the longest diagonal. So this diagonal, suppose this diagonal is the longest diagonal AB, and we have to find out the effective resistance of AB. To find out the effective resistance, you connect the point A and B by means of a battery. Suppose the EMF of the battery is equal to E or V. This is the positive end of the battery and this is the negative end of the battery. So current will flow from high potential to low potential. This is the direction of current. The current is equal to I. At B, there will be branching of current. Since the three resistors are equal, so you have one I by 3 through this resistor, I by 3 through this resistor, and also I by 3 current through this resistor. Again, when I by 3 current will reach this point, it will be divided into two parts. To this side or to this resistor, 1 ohm resistor, the current will be I by 6, and to this 1 ohm resistor, the current will be I by 6. Again, here I by 3 will be divided into I by 6 and I by 6, and at this point I by 6 and I by 6 current combine to form I by 3 and reach the point A. So you have a loop. This loop, you see, this is a loop, and you can find out the resistance between the 2 points A and B by applying KVL or Kirchhoff's voltage law to this loop. We know from KVL or Kirchhoff's voltage law, algebraic sum of the IR drop, this is IR drop in the left side, is equal to the algebraic sum of the voltage drop or EMF drop. And in this circuit you have 3 IR drops and 1 potential drop or EMF drop, and we know for IR drop we consider the loop, but for battery EMF loop is not considered. So for battery generally what we take, EMF will be is positive if the current goes from positive end to negative end. Here the current is going from positive end to negative end. So for this we take EMF is positive, negative. So here EMF E will be equal to negative, and for IR drop generally we take the IR drop will be negative if the current direction is same as the loop direction. You see, the direction of current is same as the direction of loop. So this is the direction of loop. That is why the current will be negative. So for IR drop, the current minus I by 3 minus I by 6, you have 3 currents, minus I by 3 minus I by 6 and I by minus I by 3, because resistance is equal to 1. So if you multiply R with current 1, then it will be minus I by 3 minus I by 6 and minus I by 3, that will be equal to minus E. So taking negative both the sides, it will cancel. So if you add the three numbers, then in the LCM you have 6, then I into 2 plus 1 plus 2, that will be equal to E. So 5I by 6 is equal to E. So E by I or V by I, that is equal to 5 by 6. But we know V by I or E by I from Ohm's law, that is equal to resistance R. That is why the resistance R will be equal to 5 by 6. 5 by 6 ohm. So in this way you can calculate the effective resistance of between the longest diagonal. Thank you.